This video is about finding side lengths given other information. We need to know at least an angle and another side length. We can't find the side lengths if we know just angles. Start by drawing a picture. Another thing, since we're given a side length, once we find even just one more side length, we can find the third using the Pythagorean theorem because we're working with right triangles. Let's look at this problem. We're given that side length B equals 73.6 centimeters and angle B equals 19.0 degrees. And what we want to do is find A and C. I know that this first one is a side length, not only because it's given in centimeters, but also because it's lowercase b. Capital B must be an angle because it's uppercase, and also it's given to us in degrees. Let's draw a picture. I haven't labeled this yet, but looking at this, I see that angle B is 19 degrees. Our picture doesn't need to be to scale, but sometimes it's helpful for envisioning it. So 19 degrees is pretty small. I'm going to say that angle B is up there, 19 degrees, and that means the side opposite it is side length B. So this is 73.6 centimeters. Side length A must be this side over here, the other leg, and C must be the hypotenuse. Let's find the hypotenuse first. Either one would work though. From the perspective of angle B, the information I have is the opposite side, and what I'm looking for is for the hypotenuse. Which trig function deals with opposite and hypotenuse? Sine. The sine of angle B is side length B over the hypotenuse. That means the sine of 19.0 degrees equals 73.6 divided by the hypotenuse, divided by side length C. I want to solve for C. Since it's in the denominator, what I'm going to do is multiply both sides by C. Then I have C times the sine of 19 degrees equals 73.6. At this point, I'm going to divide both sides by the sine of 19 degrees. And remember again, trig functions are always acting on an angle. I can't divide sine and 19 degrees. I have to divide the sine of 19 degrees. This becomes C equals 73.6 over the sine of 19, which is something that I can do on my calculator. I found that C is 226.0663366. We were given the first length measurement to the nearest tenth of a centimeter. That's what I'm going to round this answer to. I'm going to say that C is approximately 226.1 centimeters. To find side length A, I could do something similar. I could look at, see what information we have. We'd be working with the opposite and the adjacent, which means I'd be working with a tangent function of angle B. But that using the Pythagorean theorem might be a little bit easier. To find side length A, I know that c squared minus b squared equals a squared. So A equals the square root of c squared minus b squared. In this case, that means A equals the square root of 226.1. And if you have the more accurate version in your calculator, you might as well use that. Squared minus 73.6 squared. I ended up with A is approximately 213.7499. Again, I want to round that to the nearest tenth. A is about 213.7 centimeters. Thank you.